An egg is the ultimate culinary test. You start with the exact same ingredient every time, but its final form is dictated by heat. If you cook on autopilot, you end up with mismatched textures. A runny yolk will completely soak through a breakfast sandwich, while rubbery, overcooked curds can ruin an otherwise delicate plate. To fix this, you have to look at the process as a strict formula. Every single egg preparation comes down to just two variables: how you apply the heat and how much you agitate the egg in the pan. This chart is the texture continuum. On the vertical axis, we measure internal moisture, essentially how runny or sauce-like the egg is. On the horizontal axis, we measure structural integrity, which dictates how firm and stackable it becomes. A sunny-side-up egg sits high on the moisture scale, while an over-hard egg sits on the opposite end as a highly structured layer. When you understand these strict physical trade-offs, you stop guessing. You can precisely match the exact right technique to the specific meal you want to build. This diagram shows the thermal dynamics of a sunny-side-up egg. Because zero flipping is required, heat only moves upward from the bottom. That thermal energy solidifies the white layer, but leaves the exposed top yolk completely untouched and highly liquid. If you add a quick flip, you get over easy. That short burst of top-down heat cooks a microscopic layer of white over the yolk. The result is structurally enclosed, but maintains a fully runny center. Leave it flipped slightly longer, and the thermal arrows push deeper into the yolk. This creates an over-medium egg. The outer edges of the yolk thicken into a jam-like consistency, giving it the perfect structural hold for sandwiches without instantly leaking. Keep that heat applied until it completely penetrates the center, and you get over-hard. Because zero liquid remains, the entire yolk turns into a solid, unified block that acts as a dry, sliceable layer. If you want the top set without the physical risk of flipping, you baste. By repeatedly spooning hot fat or trapping steam under a lid, you use indirect heat to gently cook the top layer while keeping the delicate yolk fully protected underneath. Manipulating direct heat and controlling if and when you flip the egg dictates its final utility. You are actively deciding whether that egg will function as a built-in liquid sauce or a durable structural layer. Once you break the yolk and beat it together with the white, you introduce physical agitation. As the liquid warms in the pan, the proteins tighten to form specific moisture-trapping curds. For soft scrambled eggs, you keep the heat low and stir continuously to keep those curds small. You actually have to pull them from the pan while they still look undercooked, because the process relies on residual heat off the pan to finish setting that smooth, glossy texture. Hard scrambled eggs take the opposite approach. You leave them over higher heat until nearly all the moisture evaporates. The curds take on a firm, matte appearance, making them best for heavy mix-ins, like cheese and meats that would otherwise crush a softer egg. If you pour the beaten eggs in and stop stirring, you get an American omelet. Allowing that base to sit undisturbed creates a lightly browned, firm, and foldable structure designed specifically to wrap around heavy fillings. The French omelet requires near-constant pan agitation. By rapidly stirring and shaking the pan over low heat, you prevent any browning from forming and force the egg to set into extremely fine, creamy curds before rolling it into a smooth cylinder. The frittata mixes everything together in a single batch, starting on the stove to set the edges, then moving into the oven. Using ambient oven heat to finish the cooking prevents the base from overcooking while the dense center gradually firms up. When you combine the white and yolk, the physical shape and internal moisture of your meal are controlled entirely by the temperature of the pan and the speed of your wrist. This cross-section shows a boiling egg.
The shell acts as physical insulation, forcing a slow, gradual heat transfer. For a soft-boiled egg, you pull it out when heat waves solidify the outer white, but stop just before the center, leaving a fluid, spoonable yolk. Keep it in the water slightly longer, and the heat pushes into the yolk. This creates a jammy egg. It is the intermediate length. The outer perimeter of the yolk thickens into a gel state, holding its shape perfectly without drying out. Let it simmer, and heat fully saturates the center, turning the entire yolk pale and dense. At this moment, rapid cooling in an ice bath is mandatory to stop proteins from tightening further, which would turn that core dry and chalky. Because cooking inside the shell completely removes evaporation from the equation, you don't need to read the pan. The stopwatch becomes the only tool you need to perfectly calibrate internal moisture. Dropping a cracked egg into a swirling vortex of simmering water forces the outer white to instantly coagulate and wrap itself tightly around the yolk. This is the poached egg. Because it is suspended in liquid, you get perfect, even inward heating. You sacrifice the crispy edges of a fried egg in exchange for a tender, pale exterior that holds the purest, unblemished liquid yolk inside. That specific texture is the foundation of Eggs Benedict. When broken, the liquid yolk merges seamlessly with the warm hollandaise sauce. It creates a highly emulsified dual richness that relies on the toasted English muffin below for its necessary crisp base. Baked or shirred eggs take a similar ambient approach. You crack the egg into a small dish of cream and put it in the oven. Heat surrounds the egg from all sides simultaneously, setting the whites gradually without the harsh, direct contact of a skillet. Cooking in a liquid or ambient air medium delivers the gentlest possible heat transfer. You are explicitly prioritizing a delicate, tender texture over a durable, structured exterior. Submerging peeled, hard-boiled eggs into an acidic, vinegar-based brine chemically alters their structure over time. The acid penetrates and artificially firmed the egg white, infusing it with a tangy flavor while extending its shelf life. Deviled eggs achieve their distinct texture through physical reconstruction rather than heat. You boil them until fully set, then scoop out the yolks and mash them with fats and acids. The final texture is altered entirely via mixing, not cooking. In shakshuka, you crack the eggs directly into a simmering tomato and pepper sauce. The liquid sauce itself replaces the cooking pan. As the base sets, you cover the skillet to trap steam and gently firm up the exposed tops. For egg Foo Young, you combine beaten eggs with a heavy load of fillings like bean sprouts and shrimp, then fry them together. Trapped steam causes the patty to puff and crisp in the hot oil, yielding a thick, absorbent structure specifically designed to soak up savory brown gravy. The egg is versatile enough to be cooked directly by its accompanying ingredients, instantly adapting its final form to whatever chemical or thermal environment you place it in. Let's look at the texture continuum chart one more time. When we map all of these styles by their internal moisture and structural integrity, it becomes clear that choosing how to cook an egg is a calculated culinary decision. The first rule of application is simple. If your plate is dry and needs a built-in sauce, you optimize for indirect heat or short cook times. You want a poached, soft-boiled, or sunny-side-up egg to supply that missing liquid. If you are building a highly structured breakfast sandwich or batch cooking meals for the week, you need durability. You optimize for full coagulation by selecting an over-hard egg, a frittata, or a hard-boiled egg. Do not fight the physics of your pan. Once you decide exactly what texture your meal demands, simply match it to the corresponding technique, and your eggs will perform exactly how you need them to.